The next 2 pages of the Unit 3 review section looks at this data in this histogram. So the Math 075 students in fall 2015 semester were asked on a scale of 1 to 10 how intimidated they are about their math classes. So here's a histogram of those answers. Then on the couple pages, we'll see the dot plot, and we see the mean down here. The mean right here. And we have the standard deviation here. Frequency is the count, the n is the frequency, and the minimum and the max right here. And these were printed from Staccato, which is why it looks a little different than our Excel printouts, but all the information is still there. And our histogram shape is most like a bell curve. It's got that high, middle, and then a little bit on both sides. So this shape we're going to call a bell curve or normal, whichever you prefer. Those are the same thing. And it may not be a perfect bell, but it does have the highest in the middle and the highest showing that the center and the average of the data are going to be in the middle there, just like a bell shape. And it does go down the left and down on the right, somewhat symmetrically. So how many numbers are in the data set? That is our n value. So that is 478. What are the mean and standard deviation? Are the mean and standard deviation accurate? Remember, they're accurate if it's is it normal is really what it's asking here, or is it bell-shaped? If it's normal or bell-shaped, then yes, that would mean that the mean and standard deviation are accurate. Number 13, what is the average math intimidation for the students? So again, average, since it's bell-shaped, this is going to be the mean. So let's go back and find out what the mean is, which is 6.159. So I put 6.159. Now for 14, how far are typical values in the data set from the mean on average? That means, that's kind of fancy lingo, to mean, average distance from the mean is standard deviation. So let's look back on that page. What is the standard deviation? And that was the 2.418. Did I get that number right? Yeah. Okay. Number 15, calculate 2 numbers that typical values fall in between and put your answer below. And I gave you the formula here, the mean. So we have x bar minus a standard deviation and x bar plus a standard deviation. So we need the mean, which we have right up here, and add and subtract that 2.148. So I'm going to get my handy dandy calculator here. To find 6.159 minus 2.418, and then the same thing plus 2.418. And that gives me 6.159 minus 418 gives me the lower number is going to be 3.741 as your final answer here. And for the upper boundary, 6.159 plus 2.418. As your upper boundary, 8.577. Now what I want you to do here, since it's easy to make a math error, do plus or minus wrong or typo, see if this answer makes sense. Your mean is 6.159, and your upper and lower boundary should be a symmetric boundary around that center. So about 3 to 8 sounds like it's right around 6. So that sounds like a reasonable answer for the boundaries of your typical values, and that's going to give me a check. Okay, so number 16. What is let's see, I'm going to erase this because I can't see my words here. It's not erasing. There we go. What is the cutoff for unusually high math intimidation scores? So the cutoff, and the formula is down here below, is the mean plus 2 standard deviations. So that's for the high cutoff. So that's your X bar plus standard deviation twice, or 2 times standard deviation. So I'll get out my handy dandy calculator for that. And we get 6.159 plus standard deviation of 2.148, and I'm just going to add it twice. 2.148, that's the same thing as adding the standard deviation times 2. So adding it twice, say 2 standard deviations to the right of the mean, gives me 10.455. And number 17 is very similar, except this time we're doing 2 standard deviations left of the mean, which means I'm going to subtract it now. So it's the same mean, 6.159, minus the standard deviation twice. And I get 1.863 for number 17. Now 18 through 21 use that same data, but this time we're looking at the dot plot. So we've already done our calculations, so I'm going to get rid of my calculator here and looking at number 18. Are there any unusually high math intimidation scores in the data? So how do I determine that is I go back and I see what was the cutoff for the high. Here's my cutoff. Oh, sorry. Here is my cutoff. That's the fence that tells me what would be considered high. Anything higher than that. So on my graph, I draw a line at about 10.455. And I see the highest dots are actually a 10. Now these dots are kind of funny because there's so many in each group that they just end up making a vertical line. But it's just really just a bunch of dots going up that line. But the highest dots were at 10. So there's nothing above 10.444. So there's no unusually high values. So are there any unusually high? No, there's not. So we didn't answer yes, so this is not applicable. And now we're looking at unusually low math values. And so I need to get the boundary for that was 1.863. So that boundary is right about here-ish. So this is at 1.863. And if I look left of that, then yeah, I can see there are a bunch of values that are unusually low, and that's the 1. Remember, this is a bunch of dots. So how many dots are over here at that value of 1? I can tell how many by looking here on the frequency side of the vertical axis. So it looks like there's about 20 dots that have a unusually low score. So are there any unusually low math intimidation scores? Yes. If you answered yes to number 20, what are the scores? And since this was a discrete question, all the numbers were either 1, 2, there was no decimals. So it was just whole numbers, 1, 2, 3, 4 through 10. All of those unusual scores are 1. And there's 20 of them. So what are the unusual scores? I think you can just say 1. The score is always 1, but there's 20 scores of 1, just to identify that there's actually 20 dots there.